Hello everyone. Hello. Hello everyone. Hello.
Hello. Hello. Hello students, I hope you all are fine. So students, today we will do about the PYQs of unit 1, that is solution of class 12th. Okay, so students, our first question is, which of the following is an example of the solid solution? Okay, so student, that is the question of the CBSE 2021. What is example of the solid solution? I hope you all know about the solution. What is solution? Student, solution. Solution is one, it is a homogeneous mixture. It is a homogeneous mixture of two or more components. Okay. But students, here we are talking about binary solution. Components may be 2, 3, 4, 5. Okay. But we are talking about binary solution here. Binary solution means which have only two components. Which have only two components. Here students, one component will be solute. And one component will be solvent. The component which present in less amount, that is known as the solute, and which present in large amount, that is known as the solvent. Okay, so students, state of the solute and solvent, maybe both may be solid, maybe one is solid, second one is liquid. Okay, means maybe one is solid, second one is gaseous. Means in this way, on basis of the states of the solute and solvent particle, there are 9 type of the solution, like solid in solid, solid in liquid, solid in gas, liquid in liquid, liquid in solid, liquid in gas, gas in gas, gas in liquid, gas in solid, like that. Okay, so students, if both solute and solvent are solid in state, if solute and solvent both are in solid state, then that type of solution is known as the solid sol. Solid sol or solid solution. Okay, so students, what do you know about solid sol? Solid sol is that in which both component of solution, solute as well as solvent, are in solid state. So let's check. Here students, you can see your first option is C in water. C water means your solute is in sea water. Solute, one component is solute, second one is solvent. C water means salt in water, means salt in water. So your solute is salt. Solute is that which present in less amount, and solvent is water. Here salt is in solid state, but water in liquid state. So this is example of solid in liquid, not solid of solid. Clear? Then sugar solution. In sugar solution, your solute is sugar and your solution again water here. So student, here sugar, further it is solid in state and water is liquid. So it is also example of solid in liquid. So you can't go with that option also. Next one, smoke. Smoke. Smoke means smoke. Student, smoke is example of the solid in gas. Solid in gas. So it is also not example of solid in solid. Now 22 karat gold. Students, here you will take solute as copper or silver. Copper or silver, and solvent as gold. Solvent as gold. Okay, so student, here copper and silver, these are also metal and these are solid metals, except mercury, all are solid in state, so this is solid. And gold is also metal, it is also solid. So here when two or more metal combine with each other, then they form alloy. So student, it is one alloy, and here solid mixed in solid. So student, it is example of the solid solution. It is example of the solid solution. So students, you will go with option D. You will go with option D. 22 karat gold. Okay, so this is PYQ of 2021. So students, here you will go with option D, 22 karat gold. Okay, so explanation also given here. It is an alloy. Alloy means mixture of two or more metals or non-metals. Okay, so it is solid in solid solution of gold with copper or silver. Okay, so I hope students question number first clear to all the students. Okay, so now let's move to the question number 2. Student, our question number 2 and 3 are based on the assertion and region. So let's see about the question. Yes, our question is molarity of a solution change with the temperature. Molarity of a solution change with temperature. Student, first of all, you have to know about that. What is the molarity? What is the molarity? Students, molarity means how many number of moles, how many moles are present in 1 liter of the solution. That is known as the molarity. How many moles are present in 1 liter of the solution. That is known as the molarity. Okay, so students, molarity we can write like this: number of moles present in 1 liter of the solution. So student, here volume of solution given means it is depending on the volume. It is depending on the volume, and student, volume is depending on temperature. Volume is directly proportional to the temperature. Is directly proportional to the temperature. Okay, so student, because molarity is based on the volume and volume is based on temperature. If temperature will increase, then volume also increase. So student, volume is temperature dependent. Hence we can say molarity is also temperature dependent. Molarity is also temperature dependent. Okay, so molarity is change with temperature. Yes, this one is the right point. Okay, it is correct. Molarity is a colligative property. No students, in this unit we discuss about only 4 type of the colligative property. First one is relative lowering in vapor pressure. Second one, elevation in boiling point. Elevation in boiling point. Elevation in boiling point. Next one is depression in freezing point. Depression in freezing point. And last one is, that is fourth one, osmotic pressure. Osmotic pressure. So students, there are only 4 type of the colligative properties: relative lowering in vapor pressure, elevation in boiling point, depression in freezing point, and osmotic pressure. Okay, so student, molarity is not the colligative property. So this one is the incorrect. This one is the incorrect. So students, here our assertion is correct, but reason is incorrect. Okay, so let's check about the options in which it is given. In which it is given assertion is true, but reason is false. So you will go with option C. You will go with option C. So students, here you will go with option C. Assertion is true and reason is false. So your option C is the correct option for this. Okay, so in this way you will solve the questions. I hope this question is also clear to all the students. Now students, our next one question is, it is also based on assertion and reason. Assertion is molality of a solution change with temperature. Students, now it is molality. That was the molarity, that is molality. What do you mean by molality? Molality means how many moles are present in 1 kg of solvent. In molarity, how many moles are present in 1 liter of the solution. And molality, how many moles of solute are present in 1 kg of the solvent. Okay, so student, molality is number of moles of solute, number of moles of solute dissolved in per kg of the solvent, per kg of the solvent. So students, per kg, it is also mass and it is also mass. So student, it is not depending on the volume, and volume if not there, so it is also not depending on the temperature. Okay, so student, molality change with temperature, this is incorrect. It is incorrect. Molarity is temperature dependent, but molality not temperature dependent. Volume of a solution change with temperature. Yes, already I have told in question number 2, volume and temperature are directly proportional to one another. They are depending on one another. Okay, if you will increase the temperature, then volume also increase. So volume also change with temperature. This one is right. So student, here assertion is false, but reason is correct. Assertion is false, but reason is correct. In which option given? Assertion is false, but reason is true. So you will go with option D. You will go with option D. So student, here you will go with option D. Assertion is false, but reason is true. Assertion is false, but reason is true. I hope this question also clear to all the students. Okay. So now students, let's move to the next question. Our question number 4. Define the term molality. Define the term molality. Okay. So student, this question already we have got in CBSE 2017 as well as in 14. Okay. Define molality. I already told beta what is molality. Molality means how many moles are dissolved in 1 kg of the solvent. So molality is number of moles of solute present in 1 kg of the solvent. How can you write? Molality is denoted by small m. It is denoted by small m. So it is number of moles of solute, number of moles of solute divided by 1 kg of the solvent. 1 kg of the solvent. So students, if amount is given, moles are not given, then first of all you need to convert into the moles. How can you convert amount into the mole? Given mass of solute divided by molar mass of solute. Okay, if student amount given, then you can convert into the moles by using this formula, given mass by molar mass. If this mass also given in gram, so how will you convert into the kilogram? You need to convert into the kilogram. So here given weight of solvent divided by 1000. Maybe our solute, let us consider, we are considering our solute is B, and our solvent is A. Okay, so students, we can write like this also, given mass of solute divided by molar mass of solute. Okay, this 1000 we will take up inside by given mass of the solvent. Okay, so by using this formula you can calculate the molality. If we talk about the unit, so student, its unit will be mole per kg. Unit will be Unit will be mole per kg. Mole per kg. Okay, and already I told it is temperature independent. It is temperature independent. Temperature independent. I hope it is clear to all the student what is molality. So molality is number of moles of solute present in 1 kg of solvent. Okay, you can calculate molality by using this formula: given mass of the solute divided by molar mass of solute into 1000 divided by given mass of the solvent. It is temperature independent. Okay, and students, its unit is mole per kg. I hope this question also clear to all the students. Okay, it is showing that you have to learn about definitions also. Sometimes definitions can also be asked in your exam. Okay, because already they have been asked beta. So now question number 5. What do you understand by the binary aqueous solution? Students, I already told what do you mean by the binary solution. Binary means the solution in which only two components, one is solute and one is solvent. But student, here he is saying binary aqueous solution. Aqueous mean water. So aqueous solution means here your solvent is water. So student, binary solution is that solution in which two components are there. One is solute and one is solvent, and here solvent is water. So a solution containing two components in which water is the solvent is called the binary aqueous solution. Next one, define the term molarity. Okay, so molarity, students, already I told molarity is number of moles dissolved in per liter of the solution. It is denoted by capital M. If I talk about unit, number of moles, so mole per liter of the solution. So here unit is mole per liter. And students, it is temperature dependent. Temperature dependent. Okay, so student, I hope this question also clear to all the students. Okay, any doubt? No. Now students, our next one question is difference between molality and molarity. I already told about molality as well as about molarity. I hope now you all are able to differentiate between them. Okay, so students, you can differentiate like this. First thing, their definitions you can write. Their definitions you can write. So molarity is number of moles. It is number of moles dissolved per liter of the solution. Number of moles of solute dissolved per liter of the solution. Okay, and what is molality? Molality, number of moles of solute dissolved in 1 kg of the solvent. Okay, so student, it is denoted by capital M. It is denoted by small m. Its unit is mole per liter. Its unit is mole per kg. It is temperature dependent. It is temperature independent. It is temperature independent. It can be calculated by using formula given mass of solute by molar mass of solute into 1000 by given volume of the solution. Okay, and it can be denoted by formula given mass of solute divided by molar mass of solute into 1000 by given mass of the solvent. Okay, so student, in this way you can differentiate between molarity and molarity. Okay, it is volume based and it is mass based. Okay, so these points you can write in their difference. Okay, I hope this question clear to all the students. Now students, how can we change molality value of a solution into the molarity? Okay, this is also previous year question beta of CBSE 2014. So how can you convert molality into the molarity? How can you change? So students, first of all you have to know about the density of the solution. If you know about the density of the solution, so by using this formula, here M is the capital M is the molarity, here capital M is the molarity, small m is the molality into density of the solution by 1000 into 1000 by 1000 plus m is molality and mb molar mass of the molecular weight. Okay, so students, if you know about the molecular weight, molality and density of the solution, then you can calculate molarity. So by using this formula, you can convert molality into molarity and molarity into the molality. I hope student, this question also clear to all the students. Okay. Now students, our next one question is calculate the molarity of 9.8 weight by weight solution of the H2SO4 if density of solution is 1.02 gram per milliliter molar mass. This is also PYQ. Okay, so students, here first of all you will write what is given to you. So calculate molarity. We will calculate molarity. We will calculate of solution of 9.8% solution. Okay, so solution is 9.8%. Solution given, percentage of solution given students, then density of solution also given. It is 1.02 gram per milliliter. Molar mass of the solution you can calculate, but it is here given, that is 98 gram per mole. So you can write 98 gram per mole. Now student, these values are given and you have to calculate about molarity. Okay, so by using very simple formula students, you can calculate our formula for molarity. If mass percentage and density is given, so student, molarity is equal to percentage of mass into 10 into density divided by molar mass. By using this formula, okay, this is very simple formula, you can learn this. Okay, so student, by using this formula you can calculate. So here you will check, percentage is given 9.8, put value 9.8 into 10 into density is given 1.02 divided by Molar mass is given 98 by 98. So student, 9.8 I can write 98 by 10 into 10 into 1.02 by, this is 98. So they will cancel each other. So now what is left? 1.02. 1.02 molarity is mole per liter or molar. So student, this will be the value for molarity here. Okay, so students, if mass percentage given, density of solution given, and molar mass given, then by using this formula you can calculate molarity percentage into 10 by into density by molar mass. Okay, so by using this formula you can go up to your right answer. I hope this question also clear to all the students. Now students, our next one question is a solution of glucose. Molar mass 180 gram per mole in water is labeled as 10% by mass. 10% by mass. What would be the molality? What would be the molality and molarity of the solution? Molality and molarity of the solution. So student, molality. What do you mean by molality? You need to calculate molality. Molality, number of moles of solute. Already I told, number of moles of solute. Number of moles of solute divided by 1 kg of solvent. 1 kg of solvent. So students, here it is labeled 10%. So 10% by mass. So students, 10%, maybe our total solution is mass of total solution. Mass of solution so maybe mass of solution is 100. We can consider mass of solution is 100 gram. Okay. So student, here 10% solution of glucose. So glucose is 10%. Okay. So student, mass of solute, and our solute is glucose here. Our solute is glucose here. Okay. So this is student 10 gram. 10 gram. So what will be the mass for solvent? Mass for solvent will be 100 minus 10, 90 gram. 100 minus 10, 90 gram. Okay. So if you are knowing about all the values, then you can calculate. So number of moles of solute. How can you convert into the moles? Given mass of solute is 10 by molar mass for solute already given, it is 180. It is 180 into, I already told about formula, by 1000 into 1000 by given mass of the solvent, and given mass of solvent is 90. Given mass of solvent is 90. Okay. So student, by calculating this, you can get value for the molality. By calculating this, you can get value for the molality. Okay. So this is your work for today. This is your homework. You will calculate this value. Okay. Now student, our next one, molarity. You will calculate about the molarity. So already I told about the formula. If percentage given and density given, then you can calculate about the molarity. So molarity is equal to the percentage into 10 into density divided by molar mass, divided by the molar mass. So percentage is given 10 into 10 into density. Density is given 1.2. Density is given 1.2 by molar mass is given 180. Okay. So you will calculate this one also. You will calculate this one also. So this one is the molarity and this is molality. So student, you have to know about the formulas. If you know about the formulas, then you can put all values, and after calculation you will reach up to your right answer. Okay. So I hope this question also clear to all the students. Okay. Firstly students, here mass given, so mass of solute it is, so maybe total mass of solution is 100, so here solute is 10, so solvent will be 90. Okay, then you know about mass of solute, you know about mass of solvent also, so by putting value of their masses you can calculate about the molality. And if mass percentage given, density given, then in this formula you can put all the values and you can calculate molarity also. Clear to all? Yes. Now students, some questions based on the solubility and vapor pressure. Okay, till that we have done questions, they were based on the concentration terms. Okay, now we will discuss about some questions based on the solubility and the vapor pressure. Okay, these also all PYQs. Okay, you can check here. So now students, our question is solubility of gases in liquid decrease with rise in temperature because solution is M. Students, if one liquid you have, okay, students, if you will apply pressure on it, then solubility of gas according to Henry law, solubility of gas will increase when pressure will increase. But if temperature will increase, now then solubility of gas will decrease. Why is it? Because gas can be expelled out. It is exothermic process and it is reversible process. Because it is exothermic and reversible. In which option given? Option B. Option B. So you can go with option B. Your option B is the correct here. Because it is exothermic. Exothermic process means in which heat is released. In which heat is released. So it is exothermic as well as reversible process. So move on next question. Our next question is on mixing 20 ml of acetone, 20 ml of acetone with 30 ml of chloroform. Students, you are making one solution. You are making one solution. In solution, you are mixing two components. One component is acetone. One component is acetone. And next one is chloroform. Chloroform. Okay. Acetone 20 ml and chloroform 30 ml. So acetone is solute here because it is present in less amount, and chloroform is solvent here because it is present in large amount. Okay. So total volume of solution. Total volume of solution. Students, we are adding 20 plus 30. 50 ml. So solution should be 50 ml. Solution volume should be 50 ml. No, it is not 50 ml. It is less than 50 ml. It is less than 50 ml. Why? Because students, acetone molecules having interaction between them, that is known as AA interaction. Chloroform solution, when they are in pure state, they are having interaction between them, that is known as BB interaction. But if we are mixing both of them, then in solution, they are forming AB interaction. So this AB interaction, the interaction which they are making in solution, that is more stronger. That is stronger as compared to AA and BB. And if interaction is going to increase, means their volume is going to decrease. So their volume will be less than 50. Their volume will be less than 50. Clear? Because they are showing the if interaction is becoming more strong, then that type of deviation is known as the negative deviation. So student, because they are showing negative deviation, that's why their volume will decrease. So volume will be less than 50. In which option given? A. So you will move with option A. Region strong hydrogen bond causes contraction, because in AB interaction they are strongly bound due to the hydrogen bond. I hope this question also clear to all the students. Now students, our next question. An azeotropic solution of two liquids has a boiling point lower than either of two when it is. Students, boiling point when it will be lower? When your solution showing the positive deviation. Okay, azeotropic solution having more boiling point if it is showing the negative deviation, because here interaction is becoming more strong. But students, its boiling points becoming lower, it becoming weaker. Why? Because interaction is going to be decreased there. Clear? So that's why students, boiling point decreases in positive deviation solution. Okay? Why? Because in this interaction of solution will decrease. Interaction of solution will decrease. That's why they are showing the positive deviation from Rolle's law, and they have lower boiling point. Our next question is, which one of following pair will form an ideal solution? Which one of following pair will form an ideal liquid solution? Students, if solute interaction, this is solvent interaction. If you are making one solution of both, then interaction will be between solute and solvent. If this interaction is same as that of AA and BB, then that type of the solution is known as the ideal solution. Okay, in which bond strength will be same, either they are in pure state or they are in solution form. Okay, so student, chloroform and acetone, no, they are showing negative deviation. Okay, so in this way you will check N-hexane and N-heptane, they are having same type of interaction, either in pure form or in solution form. Okay, so you will go with option C. Our next question is question number 13. An unknown gas acts. Okay, one gas is there. It dissolved in 2.5 bar pressure and has mole fraction 0.04. In solution, the mole fraction of gas acts when the pressure is doubled. Students, according to Henry law, solubility of gas is directly proportional to the pressure. Solubility we are explaining in terms of the mole fraction. So student, solubility means mole fraction directly proportional to the pressure. So P directly proportional to X, students. Okay, so your mole fraction is 0.04. Your mole fraction is 0.04. So student, here what will happen if you are doing doubling of the pressure? If you are doing doubling of pressure, so its solubility will also increase. So this, it will also become 2 times. So students, here it will be 0.08. You will do 2 times only, because pressure and solubility, these are directly proportional. These are directly proportional to one another. So if it is becoming double, so it will also become double. So here you will go with 0.08. Then students, what type of deviation from Rolle's law is expected when phenol and aniline are mixed? What change in volume is expected? Represent graphically. What type of deviation when phenol and aniline? Phenol, C6H5OH. Aniline, C6H5NH2. Students, when you will make solution, then they form hydrogen bonding. Hydrogen bonding. And that is the strong bond. If bond is stronger in solution, okay, if AB interaction become more strong, then they show negative deviation. Then they show negative deviation. So here what will happen, students? They shows the negative deviation. And if they show the negative deviation, then attraction increases, so volume will goes to decrease, students. Volume will goes to decrease. So due to strong hydrogen bonding between solute and solvent in solution, okay, they are showing the negative deviation, and in negative deviation, del H will be less than 0 and del V also will be less than 0. So volume will decrease here. Volume will decrease here, students. Now, vapor pressure of pure water at a certain temperature is this: 1 mole of non-volatile. Explanation given here, students. I hope this question clear to all students. Now, vapor pressure of pure water at a certain temperature is this. Vapor pressure for pure water, P0 for water is given, that is 23.80 Hg. If 1 mole of non-volatile solute is added in 100 gram of water, calculate the vapor pressure of solution. Calculate. So it should be mole fraction of water into vapor pressure of water. Mole fraction of water into vapor pressure of the water. So student, you have to know about mole fraction. How will you calculate mole fraction of water? Number of moles of water divided by total number of moles. Total number of moles means number of moles of water, number of moles water plus number of moles of solute. In this way you will calculate now. Now you can check, students. How can you calculate number of moles of water? Given mass is 100. Given mass is 100 divided by molar mass. Molar mass for water is 18. Molar mass for water is 18. Divided by number of moles of water. So moles of water given weight by molar weight plus number of moles of solute. Number of moles of solutes are given 1 mole. Okay. So if you will calculate this one now, students. Okay, you will calculate this one. After calculating this one, you will get around value 0.847. 0.847. Okay, so after calculating value for mole fraction of water, you can calculate their vapor pressure of solution is equal to mole fraction value is 0.847 into its pressure value given 23.80. Okay, you will put the value and you will calculate this. After calculating, students, you will get around 20.16. Okay, so students, here you need vapor pressure of the pure water given to you. Okay, solute moles given to you. You will calculate for the vapor pressure of solution. So vapor pressure for solution will be mole fraction of water into its vapor pressure. So how will you calculate? Because solute is non-volatile. It is not converting into the vapors. If it is not converting into the vapors, so it is not creating vapor pressure there. Okay, so vapor pressure will be due to the solvent only here. So student, you can calculate like this: mole fraction of the water into vapor pressure of the water. So mole fraction, how will you calculate? Number of moles of that component means we are talking about water here, so you will write about number of moles of water divided by total number of moles. So number of moles of water plus number of moles of the solute. Okay, so number of moles of water, how can you calculate? Given mass is given 100 divided by molar mass, 100 by 18, 100 by 18 plus 1. So after solving, you will get this value. Then you will put this value in this equation. Okay, after putting value, you will reach up to your right answer, and your answer is 20.16. this. Now students, our last question for today: vapor pressure of pure liquids X and Y. So students, there are two liquids. One is X, second one is Y. At 25 degrees Celsius, their vapor pressure given. Vapor pressure for this given 120. And this given for Y 160. If equal moles are mixed, maybe student total mole is 1. So half mole of this, then it will be half, then it will be equal. So we can write 0.5 mole of this and 0.5 mole of this. Clear? Calculate the vapor pressure of the solution. So you will calculate total pressure of the solution. So P total is equal to vapor pressure of solute plus vapor pressure of solvent. So how can you calculate for solute? It will be vapor pressure in pure state into mole fraction for that plus vapor pressure in pure state into mole fraction for this. So student, vapor pressure for solute, or we can say X. Here we can write X. Maybe this XY. So P naught for X is 120 into mole fraction. This is 0.5 plus P naught B is 160 into, for this XB is same for both, 0.5. So 120 into 5 by 10 plus 160 into 5 by 10. So you will get 12 5s are 60, 16 5s are 80. So you will get 140. So this is your answer. I hope students, all questions clear to all students. So today we have done 15 questions of unit 1. I hope all questions clear to all. So next questions based on colligative properties and abnormal Van 't Hoff factor we will do in our next class. So thank you. Have a nice day.